Hi, we are going to present the evidence too of matter and energy, and we are Leonardo, Victor, and Angel, and me. Well, first I'm going to share the screen, and we are going to say the theoretical concepts. First one is the concept of electric field and its formula, that the electric field is a force field created by the attraction and repulsion of the electric charges, and is measured in volts per meter. The electric field is around every charged object, and the electric field causes electric charges to attract or reject each other, and this is the formula.
The second concept is the concept of electrical potential and its formula. The electrical potential is the amount of work needed to move a unit charge from a certain point to another point against an electric field. And this is the formula.
And third one is the diagram of the direction flow of the electric field between two charged parallel plates. And this is. And next one is the electric battery. A device whose function is to store chemical energy and convert it to electrical energy.
And what are the basic parts of an electric battery? Are the anode, the cathode, and the electrolyte.
And how does it work? Well, a battery stores electricity to give it at the moment that consumption demands it to transform the electrical energy that it receives into chemical energy from the reactions that occurs when two different materials, such as those on the positive and negative plates, are immersed in the electrolyte, a solution of sulfuric acid and water. Electricity flows from the battery as soon as there is a circuit connected between the positive and negative poles. This occurs when a consumer that needs electricity is connected to the battery.
What is the function of the electrolyte in a battery? The electrolyte is in charge of keeping the electrons from going straight from the anode to the cathode without the battery.
And what is the redox effect? Well, the redox reactions are chemical type reactions that lead to the transfer of electrons between the reactants, altering the oxidation state. And in this way, one element releases electrons that another element accepts. The element that contributes to the electrons is called a reducing agent. It is the element that is oxidized in the framework of the redox reaction. The element that receives the electrons is called an oxidizing agent, and this agent is reduced as it minimizes its oxidation state. Next, Angel is going to present the experiment.
Well, first of all, we have all the material, the ruler, the color, the wire color, etc. The LEDs and the cables. And well, first of all, we have the lines. Okay. Well, first I had to peel the cables, connect them into 20 centimeters long, and then peel 5 centimeters of each side of one cable, of all the cables. Then I have to connect it to the nail, around so it can be attached very well. And well, at the other part of the copper side, I had to make it a 90-degree angle. So I can see. Then I have to massage the lamps so I could drill with the nails and make it easier. Something interesting that says in the experiment is that it has to be in the peel, which actually is wrong. You have to get the nail inside of the whole line as far as you can so you can get the authenticity. At first, I couldn't make the electrode on, but with the help of a multimeter, I was able to see if the lines were having some current, and it had a 2.98 volts. There you go. Well, at the end, I used another LED, a different color, and I had to make a dark green so I could check that the LED was turning on and turning off. There you can check the difference, even if it's not much noticeable. Well, that will be everything.
Next, we are going to present the technical argumentation. Well, my name is Diego, okay? And this is what are the parts that make up the battery made with a lemon? Well, the nail will be the anode, the copper wire, the cathode, and the electrolyte will be what is inside of the lemon. And next is going to present Leonardo.
Well, I'm Leonardo Gonzalez Bustos, and I'm going to do the second one. What is the positive pole and which is the negative pole? The nail is the negative pole and the copper wire is the positive pole.
And,
Well, my name is Leonardo Alvarez. I'm going to present the point C, which asks, why is a flow of charges generated with the lemon? Yeah, well, because of the usual batteries have two metals and a suspension of an acidic solution. Both copper and zinc work fine as the metals. The citric acid inside the lemon takes the role of, you guess it, the acidic solution.
what direction does the electric field have inside the lemon? Well, it goes from the anode to the cathode.
And if there was no difference in potential between the nail and the barbed wire inserted into the lemon, would you turn on the LED spotlight? And why? No, because the difference in potential allows the flow of electrons. It being non-existent will immediately render the battery useless.
What is the function of the citric acid or lemon juice in the battery? To be the electrolyte.
And what would have happened if the tip of the nail and the copper wire inside the lemon were put together? Well, nothing. The circuit will be broken and nothing will happen.
And this is the experiment by Leo.
Well, here we can see that we have a data given that the electric potential from B minus the electric potential of A is equals to 1 volt. And the distance, we have that the distance from the nail to the copper of the wire tip, it's 20 centimeters. That is the same as 2 meters or 0.2 meters, sorry. And then we have to find the electric field. And we have this formula that it wasn't given in the course, that the electric field times the distance, it's equals to electric potential V minus electric potential A. And so solving for E alone, we have that this will be divided by B and it will be just alone. And we have the substitution that it's 1 divided by 0.2, that is the same as 5. And for the dimensional analysis, we have that 1 volt, it's equals to 1 joule over coulombs, and 1 joule, it's equals to newtons times meters over coulombs. And with this formula, we have to divide it by the meters that we have from the copper wire. And so we take these two, and it's the same as newtons over coulombs. And we have that the electric field is equals to 5 newtons per coulombs.
And that's all for this evidence too, and thank you for your attention.